So this is the 18th video on rigid body kinematics. Okay, this is in continuation of the 17th video. So in this also I'll take up numericals on pure rolling. Okay, fine. In this also I'll take up numericals on pure rolling. Okay. So I'll write down the problem. Okay. So write down the question. Cylindrical drum. A cylindrical drum of radius r rolls without slip over a plank. Okay. In each of the given cases, V is a constant, V is a positive constant, and omega is the angular speed of drum with respect to ground. Okay. In each case, find the value of V by omega r by several methods. Okay, fine. So in this question there will be three questions. Okay, each question will solve with different methods just to demonstrate the concept involved. So part A of the question is this. This is the fixed horizontal ground. This is the translating plank. This is the drum, circular drum. This plank translates at a constant speed v with respect to ground rightward. This is a plank. Center C moves at a constant speed of 3v with respect to ground. R is the drum radius. Angular speed of drum is given to omega clockwise. And here the drum undergoes pure rolling. Drum undergoes pure rolling here. Okay. Center C moves at a constant speed 3v and this moves v. V is with respect to ground. Both are with respect to ground. Okay. V is also with respect to ground. Here pure rolling is taking place. Now we have to determine the ratio V by omega r by several methods. Alright. So method 1. I'll take up method 1. Okay, fine. Now how to solve it in method 1? See, I will take the contact point of the drum to be D and contact point of plank to be P. P is the material point of plank in contact with the material point D of the drum. Okay. Now here pure rolling takes place. Since pure rolling takes place, velocity of P is same as velocity of D. But plank translates at V. Velocities of all the material points of plank are equal to V. Velocity of material point P of plank is also V. So Vp is just V. So Vd is also V. Velocity of material point D of the drum with respect to ground is also V. Alright. Now by several methods we derive the relation V by omega r. Okay. What we do, we apply SRC for velocity. Now see, SRC procedure for velocity can be applied in any frame of reference. Okay. So we apply the SRC to the point C and D to the drum. First with respect to ground and then with respect to plank. Alright. So we apply SRC procedure for velocity to the drum between the point C and D. So SP arrow C, OP arrow D. Now we draw the line joining SP and OP, that is C and D. This is C, this is D. Okay. Now we give the velocity of selected point C to point D. Velocity of C is 3v. So we give velocity of 3v to D. Now since our omega of drum is clockwise, so D moves in a clockwise circle with center at C and radius r. So for this we give a speed of omega r to D towards left. So velocity of d is the vector sum of these two. Now velocity of p is v rightward. From pure rolling criteria, velocity of d is also v. Velocity of d is also v in rightward direction. So resultant of these two should be in this direction. That is 3v should be more than this. So velocity of d will be written as 3v minus omega r is equal to v. 2v is equal to omega r on simplification. So v by omega r becomes 1 by 2. Alright. So v by omega r becomes what? 1 by 2. This is the required answer by method 1. So in method 1 we applied SRC procedure to the drum between the points C and D. Okay, in ground frame. We applied SRC in ground frame. We applied SRC to the drum between the points C and D in ground frame. Alright, fine. I'll drop this one. Now we apply method 2. We apply SRC to the drum between point C and D in plank frame. So method 2. We apply SRC procedure to the drum between its material point C and D in the frame of plank. SRC procedure to drum between its points C and D with respect to plank frame. Okay. Now see, one thing we have to note down. When we apply SRC to the drum between the point C and D in ground frame, all the velocities and angular velocities must be with respect to ground. Now when we apply SRC to the drum between the point C and D in plank frame, then all the velocities and angular velocities must be taken with respect to plank. That is the basic fundamental point. If we apply SRC procedure to the drum between the point C and D in the frame of plank, all the velocities and angular velocities have to be taken with respect to plank. If you apply SRC to the drum between the point C and D in ground frame, all the velocities in the given problem has to be taken with respect to ground frame. So before we apply SRC to the drum between the point C and D in plank frame, we must know the velocity of point C of drum and its angular velocity with respect to plank frame. First we have to do this. Alright. So first we have to determine the velocity of center C of drum with respect to plank frame. And we also have to find out the angular velocity omega of the drum with respect to plank frame. And then we apply the SRC procedure. So first we have to find the velocity of center C of the drum with respect to plank frame. Now plank translates with respect to ground with a velocity v. The formula from the formula of translating frame for relative velocity, VCG is equal to velocity of center C of drum with respect to ground is equal to velocity of center C of drum with respect to plank, VCP, plus velocity of plank with respect to ground, VPG. So VCG is given to be 3v in rightward direction. VPG is velocity of plank with respect to ground, that is v in rightward direction. And we are left with vector C, VCP. So if you simplify this, velocity of center C with respect to plank frame will be 3v minus v2v in rightward direction. So velocity of center C of drum with respect to plank frame is 2v in rightward direction. Now we also have to know the angular velocity of omega with respect to plank. But omega is given with respect to drum. Now we have to calculate the angular speed of drum with respect to plank. And this omega is the angular velocity of drum with respect to ground. And here we have to find the angular velocity of drum with respect to plank. Now again here I use that relative velocity formula for angular velocity. Omega 31 equal to omega 32 plus omega 21. So omega of drum with respect to ground, D for drum, G for ground, is omega of drum with respect to plank plus omega of plank with respect to ground. Now omega of drum with respect to ground is simply omega as given in the problem. Omega of drum with respect to plank is what we want to find out. And omega of plank with respect to ground. The plank is no, with respect to ground, plank is moving in a straight line motion. It has no rotation. So angular velocity of a translating body, that is in this case plank. See, plank is a translating body. It is moving in a straight line without any rotation. It's undergoing a rectilinear translation. And angular velocity of any translating body is 0. So omega pg becomes 0. So angular velocity of drum with respect to plank becomes just omega. Angular velocity of drum with respect to plank is same as angular velocity of drum with respect to ground. Angular velocity of drum with respect to ground is omega. So angular velocity of drum with respect to plank is also omega. Alright. And angular velocity of center C of the drum with respect to plank is how much? 2v in rightward direction. Now we applied SRC to the drum between the point C and D in the frame of plank. Alright. On this I'll rub it. So now we apply SRC to the drum between the points C and D in the frame of plank. SRC to drum between C and D in plank frame. For that we write down selected point is nothing but center C, other point is nothing but D. Now we draw the line joining SP and OP. That is, we draw the line joining C and D. Now we give the velocity of center C of drum with respect to plank, that is 2v, to other point D, 2v. Now omega of drum with respect to plank is also omega in clockwise sense. So we write down the sentence, D moves in a clockwise circle with center C radius r. So we give omega r to this D in left side. The velocity of D with respect to plank is the vector sum of these two. Now you see, this is the plank, this is the material point P of the plank which is in contact with the drum. This is the drum. P is the material point of plank in contact with the drum. Now with respect to plank, P is at rest because P is the material point of the plank. So as seen from the plank, point P is at rest. But here pure rolling is taking place. So in the frame of plank also, D will have the same velocity as point P. In the frame of plank, P has a zero velocity. So in frame of plank also, D will also have a zero velocity. So velocity of D is the vector sum of these two and is zero. So we write as what? Vector sum of these two will be what? From parallelogram law of vector addition, vector sum of these two will be 2v minus omega r, which is 0. So this means 2v is equal to omega r. So v by omega r is equal to half. This is therefore the required answer. Alright. So v by omega r becomes what? Half. So this I rub it now. Now method 3, we will solve it method 3. See, method 3 is the easiest. Method 1, method 2, you have to apply SRC, you have to write so much. Method 3 is the best method. We apply that formula for omega, relative normal speed by separation. That is the best method. See, I draw the diagram again. This is the side view of the drum. This is the plank frame, okay, fine. See, center C of drum is moving at a speed of 3v. Plank is moving at a speed of v. This is the material point D of the drum in contact with material point P of the plank. Okay. Velocity of P, as I discussed just on previous method, is v. Here pure rolling is taking place. The velocity of D with respect to ground is also v. So 3v is with respect to ground. And v is also with respect to what? Ground. Okay. Velocity of C is 3v with respect to ground. Velocity of D is also v with respect to ground. Alright, fine. Now we draw the line joining C and D. Omega is the angular velocity of drum with respect to ground. Now this line CD lies in the base plane of the drum. So angular velocity of drum is also the angular velocity of line CD. Angular velocity of drum is omega with respect to ground. So angular velocity of line CD with respect to ground is also omega. So omega is equal to relative normal speed by separation. Relative normal speed will be, normal speed of C is what? 3v rightward at right angles to this line. Normal speed of D is what? V rightward. That is also right angle to this line. Both these normal velocities are in same direction. So relative normal speed is the difference in speeds. relative normal speed will be just equal to difference in the speeds. So it will be written as 3v minus v. My separation is what? R. So this becomes 2v by r. Okay. So if you simplify this, 2v by r is equal to omega. 2v by r is just equal to omega. So v by r omega is equal to half. This is therefore the required answer. So this was the third method. This method is also a very good method. Okay, fine. Actually, we can say one more thing. Here we applied that formula relative normal speed by separation in ground frame in third method. If you want, we can apply it also in the Planck frame. That also we can apply and get the same result. So this applied in ground frame. M3. Okay. M4 what we apply this same formula in Planck frame. Omega dash equal to relative normal speed in Planck frame by separation. In Planck frame. So this are a bit here, okay? So method 4. We apply the same formula to the line CD in Planck frame. Now again, if you apply the CD in Planck frame, all the velocities have to be taken with respect to Planck. So as I discussed in method 2 of this problem, in the frame of Planck, center C has a velocity of 2v, and in the frame of Planck, vector D has a velocity of 0. Angular velocity of this line CD is equal to angular velocity of drum with respect to Planck, which I discussed in method 2, that is same as omega, angular velocity of drum with respect to ground. So omega is also equal to relative normal speed by separation. So relative normal speed will be 2v minus 0. By separation is r. So 2v is equal to r omega. So v by r omega is equal to 1 by 2. That is therefore the required answer. Okay. So I solved this method part A of the question by 4 different methods. You can see that method 3 or method 4 is the best. That is best way to solve such problems. Okay. So B and C part of question I'll solve this method 3 only. Okay, fine. I'll solve it. I'll use one more method. Okay. I'll write down the question here, part B. I'll write down the part B of the question here. Alright, fine. Part B here. Alright. So part B is this. So this is the drum. This is the center C of the drum. R is the drum radius. Center C moves at a constant speed v with respect to ground. This is the Planck. Planck moves at a constant speed of 4v with respect to ground. This v is also with respect to ground. Both are constants. Angular speed of drum with respect to ground is omega anticlockwise given. And here pure rolling is taking place. Pure rolling is taking place. Again, we have to find the value of v by omega r. Okay. This problem can also be solved by 4 different methods, as you did in part A of the previous question. Okay. This can also be solved by 4 different methods. I will not solve all of them. I just solve by 2 different methods. Fine. This I'll wrap it. Fine. So I'll solve it by, I shall write in this material point D of the drum and material point P of the Planck. Okay. I'll solve this by 2 different methods. As in part A of the question, I'll solve it by method 1 and method 3. Method 2, method 4, you solve it on your own. Okay. So this is solved by method 1. We apply SRC to the Planck C and D in the frame of ground. Okay. So all the velocities and angular velocities have to be taken with respect to ground, which is v omega, they are with respect to ground. It is given. So SRC to drum between C and D in ground frame, G frame. G frame meaning ground frame. So SP arrow what? C. OP arrow D. Now we draw the line joining SP and OP, that is C and D. This is a vertical line. This is C, this is D. Now we give the velocity of selected point C to other point D. Velocity of C with respect to ground is V rightward. So we give velocity of V to D rightward. Now omega of drum with respect to ground is omega anti-clockwise. So we write down the statement. D moves in anti-clockwise circle with C as center and radius R. So velocity D I gave R omega. So velocity of D is the vector sum of these two, V plus R omega. So velocity of D with respect to ground by third step of SRC is R omega plus V. V plus R omega. Now that is same as the velocity of point P of Planck with respect to ground, because here pure rolling is taking place. But velocity of Planck with respect to ground is same as velocity of point P with respect to ground, that is 4V. The velocity of point P with respect to ground is 4V. So V plus R omega is 4V. R omega is equal to 3V. So V by R omega is equal to 1 by 3. This is therefore the required answer. Okay. So this is solved by method 1. Fine. We'll rub this. So I solve this another method also. I do my method. I write method 2 only. I won't write this method 3. I write this method 2. So this is the C. This is the line center C. This is the drum D. D point of drum. This is the Planck moving at a speed of how much? 4V. Planck. Okay. This is point P. So we apply this formula, relative normal speed by separation. We apply the formula relative normal speed by separation to the line CD in ground frame. So see, velocity of C is how much? V. And velocity of D is how much? 4V. 4V because I stated just now, pure rolling is taking place. This is the line CD. This is the line C, this is the point D, point C, point D. C is moving at a speed V. D is moving at a speed 4V. R is the separation between C and D. Angular speed of line CD is omega, same as the angular velocity of drum with respect to ground. Now omega is equal to relative normal speed by separation. Now relative normal speed will be 4V minus VV because they are in the same direction. So omega is equal to 4V minus V by R, 3V by R. Alright. So therefore it follows from this relation V by R omega is equal to 1 by 3. So this is therefore the required answer. Alright. This is solved with method 2. See, method 2 is the best method. It is the best possible way. You just write down the velocity of the contact point. Velocity of C is given. You apply the formula omega is equal to relative normal speed by separation. You apply the formula omega is equal to relative normal speed by separation. That you get the value of required quantity. Fine. I'll take up one more example. I take the third question, part C. Part C, the diagram is like this. This is the drum. This is the Planck. This is the drum, this is the drum, this is the Planck. Planck is moving at a constant speed of 5V with respect to ground. Center C of drum is moving at a constant speed V with respect to ground. R is the drum radius. Omega of drum with respect to ground is omega in anti-clockwise sense. And here pure rolling is taking place. Again in this also we have to determine the value of the quantity V by R omega. All V omega are with respect to ground, okay? And they are constant also. Now again this problem can also be solved by 4 different methods as we solved part A of this question in this video. but I'll solve it only by two methods, as we did in part B of this question in this video. Okay, so I'll solve it by method 1. But before going to method 1, see, this is the material point P of the plank, this is the material point D of the drum, they are in mutual contact. Okay, so method 1, we apply SRC to the drum between the point C and D in ground frame. Okay, SRC to drum between C and D in G frame. G frame meaning ground frame. We apply SRC to drum between C and D in G frame, ground frame. So all the velocities and angular velocities have to be taken with respect to ground frame, as I have explained in method 2 of the part A of this question of this video. Okay, SRC to drum between C and D in ground frame. All right. So we write down, we draw the SP arrow C, OP arrow D. Okay, fine. Now I draw the line joining SP and OP, that is C and D. I give the velocity of C to point D. Velocity of C is V leftward with respect to ground. So D also I give V with respect to ground, V leftward. Now omega is anti-clockwise. So I write down the sentence. I state the sentence. D moves in an anti-clockwise circle with C as center and radius R. Now if C is center, D is to move in anti-clockwise circle. D should move something like this. Omega R. Velocity of D is the vector sum of these two. But see, P is the material point of the plank. Velocity of plank is 5v with respect to ground. Plank translates with respect to ground. So velocity of point P of plank with respect to ground is also 5v in rightward direction. Alright. So Vp is also how much? 5v in rightward direction. That is Vp. So velocity of D is also how much? Velocity of D is also 5v in rightward direction. Why? Because pure rolling is taking place here. So P and D will have the same velocity. Because pure rolling is taking place here, so P and D will have the same velocity. So velocity of P is 5v rightward, the velocity of D is also 5v rightward. Alright, fine. Now I'll rub this one. The resultant of these two should be 5v in rightward direction. So resultant of these should be this one. So omega r should be more than v. So velocity of D will be written as omega r minus v is same as 5v. So omega r is same as 6v, which means v by r omega is just 1 by 6. This is therefore the required answer. Okay. This is solved by method 1. In which we applied SRC to the drum between the points C and D in ground frame. Now, method 2, I'll solve it. We apply the formula relative normal speedway separation to the drum between the points C and D in ground frame. So, in ground frame we are applying. So, all the velocities and angular velocities have to be taken with respect to ground frame. Alright. So, I draw the line here, C. Velocity of C with respect to ground is V left. V left. Velocity of D with respect to ground is same as velocity of P with respect to ground, that is 4v rightward. So velocity of P is also 5v rightward, sorry, not 4v, sorry, 5v. 5v rightward. Alright, and this separation is R. Omega is angular velocity anti-clockwise sense. So omega is equal to relative normal speed by separation. Now the normal speeds of C and, this is D. Normal speeds of C and D are 5v and v and 5v in opposite direction. So from theory of relative velocity between two moving points, relative normal speed will be 5v plus v 6v. By separation r, that is omega. So this means v by r omega is equal to 1 by 6, which is therefore the required answer. So by both the methods, same answer has been obtained. Alright, fine. So this also I have shown, alright. This was the 18th session on rigid body kinematics. In next session also I'll take up some more numericals on rigid body kinematics. Fine. Alright. So this I will finish it here. Okay.